Newton's law of universal gravitation or the law of gravitation. This topic is indeed a long question, but it contains many short questions. For example, who formulated the law of gravitation? The question is who formulated? Who discovered? Who formulated? Newton formulated. The answer is who formulated this law? Newton formulated a law called the law of universal gravitation. The answer of this question is from here to here. Second question, define law of gravitation or define law of universal gravitation. In answer to this question, you have to write from here to here. Second short question. Third short question, write characteristics of gravitational force. The third short question is write characteristics of gravitational force. The answer of this question is from here to here. Fourth question, write applications and importance. Write the applications of law of universal gravitation, law of gravitation. In answer to this question, you have to write from here to here, 4 points. Fifth question, explain the consistency of law of gravitation with Newton's third law of motion. Fifth question is explain consistency of law of gravitation with Newton's third law. In answer to this question, you have to write from here to here. Means this topic has many short questions. This long question has many short questions. It also has MCQs which often comes in exam. For example, if distance doubles, the force becomes 1/4. Distance doubles. Double means 2 times and the square of 2 is 4. Double means 2 times and the square of 2 is 4. Distance double, force becomes 4 times weaker. If distance triples, the force becomes 19. Triple means 3 times and the square of 3 is 9, and the triple means 3 times and the square of 3 is 9. The force becomes 9 times weaker. These are some MCQs. Now let's begin. I'll start this topic from this diagram and these mathematical steps. Then I'll move towards this definition. After that, characteristics, application, and Newton's third law. Let's begin. I'll try to explain this law with the help of these two magnets. As you can see that the force of attraction between these magnets. Newton says, just like these magnets, this duster and this ball also has a force of attraction, but the force is very weak because of their smaller masses. Not this duster and this marker, or these two markers, they all have the force of attraction between them, but the force is very weak because of their smaller masses. But the force between this ball and the earth is very strong because of the greater mass, huge mass of the earth. This force depends on the mass. If I release this ball, it will move downward because of the stronger force. This duster and this ball has a force, but the force is very weak because of their smaller masses. But the force of between this ball and the earth is strong because of the earth's huge mass. This force depends on the mass. Huge mass, greater mass, stronger force. Smaller mass is weaker force. Not even we can feel it. Now, means the force depends on the mass. Force is directly proportional to the mass. Greater mass, stronger force. Now, means smaller masses, both have smaller masses, weaker force. Earth has greater mass, stronger force between Earth and the ball. Means as mass increases, the force also increases. Means they are directly proportional. They are directly proportional. Directly proportional means if one quantity increases, the other also increases. It means they are directly proportional to each other. Now, that's why the force between Earth and the Sun, the force between Earth and the Sun, because of their huge masses, they have strong force between them. That's why Earth doesn't drift away in the space from the Sun and revolves in its orbit. Same, there is force between Earth and the Moon because of their huge masses, their greater masses. There is a strong force between Earth and the Moon. That's why Moon doesn't drift away from the Earth into the space and revolves in a fixed orbit around the Earth because of this strong force. Now, smaller mass is weaker forces, greater mass, strong force. As mass increases, the force also increases. Means the force has direct relation with the mass. Now, look here. As distance increases between the magnets, the force decreases, and here no force between the magnets. And as distance decreases, force increases. Distance increases. R is the distance between the masses. R is the distance. As distance increases, force decreases. One increases, other decreases. Look here. Distance increases, no force decreases. Distance increases, force decreases. R is the distance, or R is the distance between these magnets. You can represent distance with R, with D, with L. Now, means one increases, other decreases, means force has inverse relation with the distance. These two are the mathematical steps. Here we have two masses. In here also, as if we bring this ball to a certain height in the space, the force of the earth on the ball will be almost zero and the ball will never come back to the earth. Same just like these magnets. Here we have two magnets, M1, M2, and R is the distance between them. The force is inversely proportional to the square of the distance. Now, if we convert, listen carefully, if we convert these two mathematical statements into the theory, it will be the definition of this law. How we can convert? It's very easy. Look here. Force is directly proportional to the product. Product means multiplication. These both are multiplying. M1 multiply M2. Force is directly proportional to the product of masses. Directly proportional to the product of their masses, and force is inversely proportional. One increases or decreases means they are inversely proportional. Inversely proportional is written 1 over. Inversely proportional to the square of distance. R is the distance between the masses and here square. I'm not going in detail of this square because students may get confused. R is force is inversely proportional to the square of distance. Inversely proportional to the square of distance between their centers, between the center from this center to this center. So these two mathematical statements are a definition of this law. Now look at every object in this in the universe, even two human beings standing close to each other, have a force of attraction between them, but neither of them can feel it because it's a weaker force, and the force is weaker because of their small masses as compared to the earth, but they have a force. Every object in the universe attracts every other object. Every object, this object, this object, this object, this object, human beings, every object in the universe, this object, this sun, this moon, this earth, every object. Look here, this sun, this earth, this moon, this marker, this duster, this ball. Every object in the universe attracts every other object with a force. With a force that is directly proportional to the product of their masses. Directly proportional to the product. Multiplication means product of the masses. And inversely proportional to the square of distance between their centers. Inversely proportional to the square of distance. R is the distance and square of distance between their centers. Square of distance between their centers. This is the definition of law of gravitation or Newton's law of universal gravitation. Hope you got the point. Now, by combining these two, m1 m1 m2 divided by r square, m1 m2 divided by r square, and f is here. By combining these two, we get this equation. Now, whenever we convert proportionality into equality, a constant comes. This g is the constant, f as it is, m1 m2 over r square, m1 m2 over r square as it is. Here f is the gravitational force, m1 m2 masses of the objects, mass of this object and mass of this object, or distance between the objects. R is the distance between the objects or between their centers. G is the constant. G is the constant, gravitational constant, and G has a constant value 6.67 multiplied by 10 to the power minus 11 Newton meter square per kilogram square. This is the units of G. Now, and Newton formulated or discovered this. Newton formulated. This formula was given by the Newton. This formula is given by Newton. Newton formulated this law. A law called law of universal gravitation to describe the force between all the objects in the universe. To describe the force between all objects, this object, these objects, this object earth, this object moon, this object sun, to describe all force between all the objects in the universe. Hope you got this. Now, characteristics of gravitational force. Some student get confused because of these units. Look here, it's very simple and easy. Find the value of G. r is dividing, it will be multiplied in this side. F multiply by r square, m12 is multiplying here, they will be divided to the other side, m1 m2, and g is left here. Now look here, force is measured in Newton, r is the distance and distance is measured in meter, r is the distance and the SI unit of distance is meter. SI unit of force is Newton and distance is meter, and square meter square. SI unit of mass is kg, kg square, kg square, Newton meter square per kg square, Newton meter square per kg square. This is the unit of g, SI units of g. Now, characteristics of gravitational force. The first characteristics, it is always attractive. Earth always attracts towards itself. Earth never repel this ball in upward direction. It always attracts towards itself. So it is always attractive. Gravitational force is always attractive. It acts along the line joining their centers. It acts along the line, joining their centers. Joining this and this center, joining their centers. It doesn't depend on the medium. Now, what is medium? What is medium? Anything between two other is known as medium in this case. For example, one object is earth and other is ball. Now, distance between earth and the ball is medium. Medium can be a duster, medium can be air, medium can be a glass, medium can be a plastic, even medium can be a vacuum. So anything between two objects is medium here. So it doesn't depend on the medium. The force of earth on the ball doesn't depend on this medium, this duster. The force is not affected by this medium. So it doesn't depend on the medium. It obeys the inverse square law. What is inverse square law? Inversely proportional to the square of distance. This is known as inverse square law. So it obeys the inverse square law. If distance doubles, the force becomes 1/4. Distance doubles, force becomes 1/4. Double means 2 times, and the square of 2 is 4. So distance doubles, force becomes 4 times weaker. If distance triples, triple means 3 times, and the square of 3 is 9. If distance triples, distance between the objects is triple 3 times, then the force becomes 9 times smaller. So as distance increases, force decreases rapidly. Now, applications and importance. Application of this law of gravitation. First application, explains motion of planets, moons and stars. This law explains the motion of earth, moon, sun. How? This law tells us that there is a force between earth and the sun because of their huge masses, their greater masses. Greater mass, stronger force. So between earth and the sun there is a stronger force. That's why this earth revolves in the orbit and doesn't drift away from the sun. because of the strong force. And this law tells us that there is a strong force between sun and the earth. And also there is a strong force between earth and the moon because of the huge mass of earth and moon. That's why the moon revolves around the earth in its orbit and doesn't drift away from the earth into the space. So this law explains the motion of planets, moons, earth, sun, stars, etc. Also explains tides due to moon's pull. Now focus here. 71% of the earth's surface is covered with water, with sea. For example, this is the earth, and almost 71%, I think this is the 71, almost 71% of the earth. 70, this green is 71% and the remaining is 29%. 29% is land where we live, and the 71% of the earth is covered with water, with sea. Now tides in the sea, in the ocean, there is a force here at this point. At this point the force is stronger. At this point the force of the moon at this point is stronger, and the force of the moon at this point is weaker. So when move revolves around the earth at this point, when moon reaches at this point, the water level rises a little bit because of the stronger force at this point, and water level arises and tides start. Because of this rise in water, tides are produced here and also in the opposite side. So it explains the tides due to moon's pull. Because of the moon's pull, tides are produced. This law explains us that. Now forms the foundation of classical mechanics. This law forms the foundation. Here another short question arises. Note down the question. The question is law of gravitation still applicable in this modern era? The answer is yes, applicable. The answer is from here to here, still used in modern physics and astronomy. Astronomy is the study of galaxies, earth, moon, sun, etc., stars. Is used in modern physics and astronomy, although later refined by Einstein theory of relativity. The Einstein theory of relativity also supports or confirms the law of gravitation. Now, consistency with the Newton third law of motion. Consistency of law of gravitation with Newton's third law of motion. Let's quickly recall the Newton's third law of motion. Newton's third law is every action has reaction which is equal in magnitude but opposite in direction. Which is equal in magnitude but opposite in direction. This is the Newton third law. Newton third law. Every action has reaction which is equal in magnitude but opposite in direction. Is law of gravitation obeys these 2 points, Newton third law, or not? Let's check. First we will check the opposite in direction. Look here. M1 attracts M2 towards itself, means the force is in this direction. Let me repeat this. M1 attracts M2 towards itself, means the force is in this direction, and M2 attracts M1 towards itself, means the force is in this direction. Both are in opposite direction. Look here, the second point is confirmed. Both are in opposite direction. Equal in magnitude. Both forces are equal. Let me explain this with an example. If I exert force on this wall, the wall exerts same force on me to stop. Both forces are equal. It's impossible the wall exerts a stronger force and push back towards opposite side. It's impossible. Both forces are equal. Same here. Both forces will be equal. So equal in magnitude or opposite direction, it means this law of gravitation obeys Newton's third law of motion. Now what is 1, 2 and 2, 1? F12, force on 1 by 2, force on 1 M1 by M2, and F21, force is on M2 by M1, which is in this direction, and F12 is in this direction, this and this. Now look here, F12 is equal to F21, both are unequal. This negative sign shows both are in opposite direction, equal in magnitude but opposite in direction. 1, 2, force exerted on M1 by 2 by M2 on 1 by 2. F21 on M2 by M1, force exerted on M2 by M1. Both F1 and F12 are equal in magnitude but opposite in direction. So Newton's law of gravitation, means this law, is consistent, obeys, is consistent with the Newton's third law of motion.